So next we'll look at question number 3 from tutorial chapter 8. Light of wavelength 5 times 10 to the power negative 7 meter passes through two parallel slits and falls on a screen 4 meter away. Adjacent bright bands of the interference patterns are 2 centimeter apart. So what we have in the question is a Young's double slit, as we have two parallel slits. So this is a double slit question. So given to us wavelength lambda and falls on a screen 4 meter away is our capital D. So what we have here is a Young's double slit where the screen is located 4 meter away from the slit. So the distance between the slit and the screen is 4 meter. Okay, so the light shown here is with a wavelength of 5 times 10 to the power negative 7. Okay, adjacent bright bands of an interference patterns are 2 centimeter apart. Okay, what is this adjacent bright band with a 2 centimeter apart is actually the distance between two bright fringes. So what is going to happen for Young double slit? You're going to have a central bright here, central bright, and then you're going to have your first dark fringe, first bright fringe, second dark fringe, second bright fringe, third dark fringe, and you're going to have the next third bright fringe, and so on, and it continues. So 2 centimeter is what we call as delta y. Delta y is the distance between any two adjacent bright fringes. Okay, so the distance between the bright and bright is what we call as the delta y, adjacent distance. Okay, so the first question here is to find the distance between the slits. So what we want here is this distance here, D here. Okay, so since given to us delta y, we are going to use the equation of delta y, which is equals to lambda d over small d, to find my small d. As the value of delta y is given, lambda is given, capital D is also given, I can easily find my small d. So my small d is going to become lambda 5 times 10 to the power negative 7 multiply with capital D 4 meter divided by my delta y, which is 2 centimeter. And then I will end up with D as 1 times 10 to the power negative 4 meter. So this is my small d here, the distance between the slits. Next here, the question asks to find the same two slits are next illuminated by a light of a different wavelength. Maksudnya now, you're going to illuminate this slit here, this particular slit here, with another wavelength, lambda nu lambda, which the value is not given in the question. So what we have in the question is, the two slits are next illuminated by light of different wavelength, and fifth order minimum for these lights occur at the same points on the screen as the fourth order minimum for the previous light. What is the wavelength of the second source of light? So basically we are going to look for this wavelength, but what we have in the question is, I'm going to draw it so that we can see it in a better view and we can understand it better. So what we have here is, you're going to have Young double slit, and this is your screen here. So when you are using lambda 1, this is your central bright here, central bright, you're going to have fourth order minimum, previous light is lambda 1, fourth order minimum means dark fringe, yang m is equals to 0, first dark fringe, second dark fringe, m is equals to 1, third dark fringe, m is equals to 2, fourth dark fringe, m is equals to 3, and then fourth order minimum. Okay, so what happened here is, when you use this wavelength, you're going to get a fourth order minimum at a distance of, let's say I call y, from the central bright. This is where I get my fourth order minimum. So now let's say when I change my light to my second wavelength, lambda 2, which is unknown. What happened here is I'm going to get my fifth order minimum. I'm going to get my fifth order minimum on the same point as the fourth order minimum. So now when you change to lambda 2, at this fourth order minimum, what you actually get to see is a fifth order minimum, m is equals to 5. So what happened here is all your fringes here becomes much closer to each other. M is equals to 0, m is equals to 1, bright, dark, m is equals to 2, bright, dark, m is equals to 3, bright, dark, m is equals to 4, and then m is equals to 5. At the place that you're going to get the fifth order minimum is the same as you're going to get fourth order minimum for two different wavelengths. So when you change the wavelength, what happened here is you're going to get a fifth order minimum at the same spot. Okay, faham ke? Cuba faham melalui gambar ni. Cuba faham melalui gambar ini. Bila kita guna lambda 1, at titik, let's say saya panggil titik M ni, dekat titik M ni, awak dapat, tak nak guna titik M lah, kita guna titik P. At titik P ni, you get M is equals to 4. But when you change the wavelength to an unknown wavelength, dekat titik P ni, apa yang awak dapat adalah fifth order minimum. Awak dapat order yang ke-5. Okay? Alright, so the question is, what is the wavelength 2 here? Kita baca balik soalan. Selepas kita tengok diagram ni, kita baca balik untuk understand the question. The two same slit is next illuminated with light of different wavelength. So sekarang kita guna wavelength lain. And the fifth order minimum for this light, for this new wavelength, the fifth order minimum occurs at the same point on the screen as the fourth order minimum of the previous light. Okay, faham ke? Maksudnya pada titik yang sama ni, awak dapat fourth order untuk previous light, tapi awak dapat fifth order untuk the next light. Okay? So the question asks to find the wavelength of the unknown source dekat sini, unknown light dekat sini. Okay, so kita nak cari lambda 2 here. So for my lambda 1, which is equals to 5 times 10 to the power negative 7 meter, order yang saya ada dekat sini adalah fourth order, fourth dark fringe. Fourth dark fringe, bukan, dia kata fourth order minimum. Maksudnya M saya memang sama dengan 4 sebab dia dah cakap order kan. So M saya sama dengan 4 dekat sini. So according to the Young's double slit destructive interference, Y4 is equals to, ataupun kita tulis general equation dulu, Ym is equals to M plus half lambda D over D kecil. So ini adalah Y4 is equals to 4 plus half. Lambda saya adalah lambda 1. Lambda 1 here. So I'm going to substitute the value of my lambda 1 here. Lambda 1D. Lambda 1 is 5 times 10 to the power negative 7. My D here is 4 meter. And D kecil kita dah cari tadi dekat atas. 1 darab 10 negatif 4. So what you can do is you can find your Ym here. Y4 here. Okay, once you have got your Y4, you know that this Y4 here is equals to Y5. Okay, sama, jarak mereka sama. Okay, so Y5 occur at second wavelength which is unknown, where the order is equals to 5 here. So Y5 is equals to M plus half lambda 2D over D kecil 5.5 lambda 4 1 times 10 to the power negative 4 equals to you get 220,000 lambda 2 here, which is equals to your Y4 sebenarnya. Y4 kamu tadi adalah jawapan daripada sini. Samakan and you can get your Y2. Alright. Yang penting adalah you should be able to come up with this one daripada soalan ini.